I'm now going to look at one specific example of using electromagnetism. A power station is only able to generate somewhere around about 3000 volts per generator in the power station. The voltages that are used to transfer electrical energy all across the country, we're looking at 240,000 up to 400,000 volts, okay, across the cables that you see between the pylons. So how do we get from 3,000 up to 400,000? And then how do we get back down again to 230 volts that we use domestically in our houses? Everything you plug into your house is working off 230 volts mains. Well, that's actually done using a thing called a transformer, and I've got one set up here. It's just two coils, okay, connected together with the same core. And what I'm going to do is I'm going to use the power pack at the back here. I'm going to set it to 2 volts, and you can see in the corner of the screen there the voltmeter, which is going to measure the output voltage. So this is my input voltage and this is my output voltage. I'm going to try and keep this at 2 volts. The input number of coils, you can actually see here, is going to be 60, and the output number of coils is 120. So what happens when I switch on? Now remember, this is 2 volts here, and you can see I'm getting just over 4 volts out. Twice as much voltage. And if you look at the number of coils, it was 60 in and 120 out. So I've got twice as many coils in the output as I have on the input. So my output voltage is actually in the same ratio, okay, as the number of coils compared with the input. 2 volts in, just about 4 volts out. 60 turns in, 120 turns out. Okay, twice as many. I've now altered the number of coils, so it's still 60 for my input, but now my output is 240. So I've got 4 times the number of coils in my output as I have on my input. So let's see to the output voltage. Again, 2 volts in, and I'm getting just over 8 volts out. Again, about 4 times as much output voltage compared with input voltage, and that's in the same ratio as the number of coils. 60 in, 240 out. Those were both examples of what we call step-up transformers. We're actually able to increase the voltage, okay, that's coming out. What I've done now is I've actually swapped round the number of coils, so I've now got 240 on my input and I've only got 60 on my output. And again, when I switch on for 2 volts, in the corner of the screen you can just see the output voltage there. So this time I'm stepping down by a factor of 4. And again you can see my voltage is actually stepping down in the same ratio. Right? It's about a quarter of what the input would be. And one last one on this. So again I've changed it. So I've only got 120 on my input now, and I've still stuck with my 60 on the output. So I've got twice as many coils in my input as I've got in my output. So in this case I should actually step down the voltage again by a half. And you can see here, if it's 2 volts in, I'm only getting just over 1 volt out. So again, this is a step down transformer, and the voltage is decreased in the same ratio as the number of coils.